I gather that one of the major philosophical or ontological problems with many worlds is that it doesn't have the local variables. And I'm wondering if there's a similar ontological problem to the spontaneous collapse theories or something basic like that. Or, I mean, as you put it, Timur, it just kind of makes you uneasy. You're uncomfortable with it.
So, two things about the collapse theory. One is just the collapses, okay? Especially if it's this trading off dynamics that a lot of the time it's Schrodinger and then all of a sudden it's something else. That's what you find in like von Neumann's book. And then if you associate the collapses with measurements, then you're in a complete mess, right? That's just a disaster. The GRW theory also has the original
wait, before you go on, is it a complete disaster because then they're not spontaneous any longer?
It's a complete disaster because you don't know what a measurement is. Okay. This was the objection that Einstein said, can a mouse do it? An observation, can a mouse do it? What interaction counts as a measurement?
Should the notion of measurement play a fundamental role in the very formulation of a physical theory? I think most physicists nowadays would say absolutely not.
And that's the point. Again, go read Bell's Against, quote, measurement. He makes the point very, very, very sharply that the term measurement just should not appear in a fundamental theory because it's not a fundamental notion. Mm-hmm. It's like pianos. I mean, there are pianos, they exist, that's okay, but you shouldn't have to mention pianos or have to figure out whether a collection of atoms constitutes a piano in order to figure out how the laws of physics go, right? Mm-hmm. That's not on. If someone suggests that, you're just going to say, no, this is not on, right?
Oh, but then, Tim, maybe your idea of having electrons shaped like Mickey Mouse is not such a great idea.
Yeah. So there's that part. Now, I should mention that Philip Pearl has a kind of collapsy view, but it's not one with this alternation between Schrodinger and collapse. It's it's called a continuous collapse or a continuous reduction theory. Quite honestly, I see the pull of that, because if you don't like this alternating between this dynamics and that dynamics, okay, just have one dynamics. It is a fundamentally indeterministic dynamics, always operating in the same way. To me, that feels better. The other question you asked is, well, what about the local beables? Now, this is a question that kind of got worked out in my living memory. Shelley and other people working with him clarified this. It was very helpful just to have a little piece of terminology. So there is a theory called GRW null with a little null sign in front of it. That means a theory where the ontology is just the wave function and it follows the GRW dynamics. That theory, I think, is in deep, deep trouble because it also has no local beables because all it has is the wave function. It's now a collapsy wave function, but it has nothing local in it. Then there's the theory that Bell himself suggested in his paper, Are There Quantum Jumps?, where he introduced this idea of flashes, the flash ontology. Flashes are physical events in space-time, points in space-time. If you didn't like point particles, you'll like this even worse. Points in space-time, they don't even persist, right? And what Bell did was he said, well, if I've got this GRW collapse theory with these sudden collapses, those collapses are centered at space-time points. So I can put those in. I have to postulate them. They don't come for free. I can postulate that there are these physical events in space-time that happen when these collapses occur. And they're distributed in space-time. And if you kind of squint at them, there are enough of them that you'll see tables and chairs and cats and planets and stars and everything else at macroscopic scale outlined by this collection of flashes. So then that doesn't have the problem. Then Giancarlo Girardi didn't like that too much. So then they tried to come up with another theory, which was the GRW dynamics with a matter density ontology. So it doesn't have this discrete flashy character. It's more like a continuous field that you define down. And that behaves in a different way and has different issues with it. So I would say GRW null, yeah, that's as bad as many worlds. GRWF, it has some technical nice advantages. GRWM, some of the advantages go away. Bell liked GRWF for various reasons that he gives in the paper, because he thought you could make it into a relativistic theory.
The M, when Tim said this, the M, that's an M. That's a field on physical space, not on the space in which the wave function lives. It's crucial here that it's projected down to physical space. This primitive on top, the local beables are normal local beables on physical space. That's the M, the mass density, distributed over physical space.